Welcome back to our Scala to Spark class, and today we will talk about regression. We'll start with the simplest one, which is linear regression, which means we have some data and we want to find the line which best fits the available data. And of course, the line follows a simple formula, linear formula, so that means we can always make predictions on the future. So that's the simplest type of regression there is. It's been around forever, and so again, so you have some noise. Well, you said some data. Of course, it's only applies when your data is, well, there is some linear relation. Of course, not all type of data are useful, don't have a linear dependency, but it is a good starting point. So let's take a see how to do this in Spark. I will also need to create some data, so I will I'll make a new file how to make some fake data. I'll make it instead of loading it from the book, but I will actually make some data. So day 35 create data, regression data, right? Something like this. Oh no, sorry, that should be day 37, right? Right. I'll rename it. Refactor name day 36, right? Yeah, of course nobody's using it, and also, yeah, okay, great, it worked. Okay, so extends app, and I will want to create something. Of course, I'll create Spark, right? And so Spark equals get Spark, right? Sparky on. So this is on. Let me save it while destination will be something like source resources. I'll do CSV, let's say range 100. And of course, then we can, so I'll create a data frame, right? Something like Spark, right? And so range will give me a range of numbers, right? 0 to 99, right? And I'll convert this to 2df, right? Yep, that's what we do. And I guess you can leave it empty, doesn't have to worry. So now we're gonna rename it, right? This is gonna be ID is gonna be X, right? So this column renamed, right? We're just gonna rename the column. We'll call it ID will be X, right? That makes sense, right? And okay, new name X, okay, and starting this data frame already here. So and we'll create a new column, this column, and we'll call it Y. Well, makes sense, right? And that will be our fake data, right? And we'll come up with some formula. So let's expression round. Do we want round? Let's say 3 digits after a comma, maybe. Let's say X times 4 plus, let's say, I don't know, 5 plus some random noise, randomness, right? Minus 0.5, because random is from 0 to 1, so we want a little bit of noise maybe, and this is what formula ends, right? And we want comma, right? Did I do it correctly? I guess not. No, sorry, here, comma like this, right? And we need, of course, this is expression like this, yeah. Okay, we need to close this. Why it's not closed? Okay, we need to close this, right? Okay, and we need to import expression, of course. Okay, round, and yeah, so x4. So we have, this is the formula, but we have some noise. We add some noise to our formula. So our linear formula has some noise, right? Just to simulate some fake data. And so that's gonna be df show, let's say 10, right, false. Let's see what we have, right? See if this works actually. Okay, so we see nice little formula, right? So that fits. First value is 4.9, right? We didn't set a seed, by the way, randomly, right? So 4.9, yeah, makes sense, right? And then it goes up by 4, roughly by 4 each time, right? So again, simple data set, and we'll need to save it, of course, xy, right? So we want to save this data set, and so we'll use Zego right, remember, right, format CSV, or we could do CSV actually, right? I guess we could do this format CSV, and, right, or we could do CSV, option will be path, right, destination, right, and mode, right, we could do we want header, let's do header, right, we can of course save it as a Parquet file as well, header true, right, and we also have mode override, each time we'll create a new one, right, and we want to save it, right, okay, so let's run it, see how our data, this will be slightly different data of course, because I did not change seed, so each time we run it, no seed is set, so each time should be different, random noise, right? Okay, so ex of course, so here we have so our formula is fx equals 4x plus 5, right, plus noise, plus some noise, random noise from -2, right? Okay, that's our formula, right? But we of course, right, we are just gonna, we'll want to figure out if how close do we get to 4 and 5, right? How close can we extract these values? Again, this is simple linear relationship, so we'll try to extract. Okay, let's save it. It's running. Okay, so we saved this slightly different data set, of course, right? So let's take a look. Do we have it in our files somewhere here? Range 100. Yes, we do have it. Right, let's check it out. Yeah, it looks okay. X, Y, and we have some values. Okay, very nice. Okay, we have an X and Y values, and we should be able to do something with these. All right, and let's commit this. Right, so let's commit this. We'll add this, and also I want to change, I guess I'll add everything here. Alice and CSV range, I guess I'll add, actually I want to only add, alright, I'll add all of it, right, data 36, data for regression, okay. Okay, so now we are good to go. Now we actually need to use it for our read the data, right? So, okay, we have the data. We don't have to. We can keep this or irises. So again, we are trying to predict quantitative values. Okay, so again, so when do we use it? Basically for company revenue, movie viewership, right? Predicting crop yields and so on, right? So otherwise, in some ways, it's very similar to what we did before with classification, right? So it's except we have we use different algorithms, but ideas, the data preparation will be similar, right? We'll have some, we'll have the features, right? Numeric double features, vector of features, and we'll also use, or predictions are just quantitative also values, label, or labels. Instead of labels, we'll have the features basically. Okay, so how do we do this? Let's load the class, let's start a new class. Day 36 regression, of course object, and extends app, and we will do it. So print line, chapter 26, I believe, right? Regressions. Of course, we'll get Spark. Okay. Right, and we will want to do some work. So again, so some use cases, right? So there are again some models, right? Again, there will be more. We can check actually what's available in our what type of models are available. MLlib, Spark 3.2. Let's take a look, right? All right, this is 3.3 actually. Well, okay, but this should be very similar, right? I don't think there's anything new, right? So we have classification, regression. We have some interesting ones. We have, of course, starting with linear regression. We have some other ones, including, of course, there's even decision tree regression, which is kind of interesting, right? So not too many, but we have a few choices here, right? So we can start, of course, with linear regression again. So trying to fit a line fitting basically. Okay, I will, all right. And of course, as usual, this is basically or just a basic rough overview of regression methods. There are other methods of regression available, right? But this is just a, just a start to get you started. All right. So again, as usual, we want to have to pick the data. There's some interesting talk about scalability, of course, because again we are interested in processing large data. Again, linear regression works quite nicely, even up to starting with one feature. Like in our simple case, we only have one x, right? A simple x, right? We don't have x2, x3, x4, right? We only have single feature, right? But we can train it, no limit really. Isotonic. Some of them are slightly slower, of course. Again, right? Again. So let's see how close do we get. So we want to load the data. This is going to be what our source path, right? Will be well, source will be I think source, resources, and CSV range 100, right? Something like that, right? Okay, that's our source, and we will load it, right? So val df equals, of course, Spark read. I think we do read. I think I forgot. I think read CSV. What did I forget now? Read. Yeah. Format, of course, CSV. What else do we need? It's let's take a look. We have a header. We do have a header, right? We want to include a header. We want to infer the schema, right? And we want to provide where to load it from. Let's see if we can do this here. So option header true, right? We do have a header in this case, right? Again, option infer schema, right? Infer schema true, right? And I guess can we load it? Yeah, we can do load source. I think load source would be fine, I believe, right? We could also use option path source and load. Again, that would be also right, but this should work. Okay, and let's take a look. Df show, let's show 10. Okay, let's run it. Okay, we have the data read. Looks good. X, Y, names are headers preserved. We have the data. Everything great. Okay, so we can proceed. So what else do we want? So of course now we need to once again prepare features as a vector. In this case, vector with single value, right? In each row, right? So what's easiest, of course, is to use our formula, right? Let's do that. So our formula, right, we'll do, or RF maybe, right? Our formula will be new our formula. Let's see. Can we do it here immediately? Let's import it. Can we do it here? No, I guess not. We have to do it here, right? Set. So set formula, and we'll do it, of course. So y is our prediction on the rest. So here rest will be, right, rest of columns. So y is the label. So y is the label. On the rest here just once x column, right, are the features, right? So let's take a look, and we not of course fit it. So well prepared, right, or we'll call it df prepared, or maybe df prepared, transformed, right, vectorized. Maybe I could call it, I don't know what you call it, just ndf maybe. I'll call it ndf, right? Will be our formula, right? Fit, right? Fit df, right? On transform df, right? So we prepare it, prepare the data, right? You know, on transform the new, transform into a new data frame, right? Okay, so let's take a look. ndf show, again, things we have done before. Let's take a look. Okay. Did I not show it? Okay, it finished running. Okay, yeah. All right. So features and a label, right? Again, of course, we could here we could say set. We could do set label column, right? Of course, right? We could do, you know, and of course we could also say features, of course, right? You know, default is indeed features, right? And again, you notice set label. Set label, sorry, features column, right? Of course, this is features, right? We don't want to reverse it, right? I mean, we could, I mean, these are just words, right? But, you know, again, features is the default already, right? So, again, default is indeed label. Right. Of course, this might be slightly more explicit again, so you know what's going on. Again, so you know. So by surprise, right? So now we're ready to go. Of course, we don't really need the label because we already have y is already transformed. I mean, it is not necessary, strictly not necessary. We could have skipped this column here, right? Again, this is extra preparation work. So how do we create the model? It's very similar to how we created our classificator model. We basically create a model. We'll call it linreg, for example, right? And this will be, of course, new linear regression, right? Yeah, there it is. That's the one. IntelliJ is really in good shape today. It's telling me ahead of time what I can and cannot do. Okay. Did it automatically pick up? Yeah, it did. Fine. You see regression. So we can now, do we need anything else? Yeah, we could, of course, we could check again, we could check here, of course, we could say which one we want features and label, we could or y, right? We could say maybe we'll call it. It's not really a label, right? It's a, I don't know what you call it, a result, right? Maybe result, or I will call it a big y, just small y, but y is already here, so you know we don't have to call it maybe result, you know, value maybe, right? Right. You know, this is just the cosmetics, of course, pure cosmetics. So yeah, now we want to run it, right? So we'll set, we need to check something called set label column value, right? Right, of course, again, yeah, we could also use y, right? We could also use y, because y, they're exactly the same, right? We could also use y, of course, right? So I mean, I don't think label is not really, well, they use label even in a regression, but it's not really I mean, it is a label, but it's an answer, it's a result, more like a value. Label to me is something more categorical, at least to me, but okay. Right, so let's do this. So first of all, we could check what parameters are. Right, NDF is here, or transformation. Right, now let's see how much time we have. We're doing pretty good today, so maybe shorter, simpler methods. So we can also, of course, again as usual, we can in reg explain parameters. Right, if you want to see, we can check what parameters we can adjust, right? Of course, we could just look up here, right? We could do our friend here, right? We could look, of course, look up here, right? Oh, max iterations. There is actually some things you can set, right? So this is also we could also look up here. Right? All right. Now let's run it and see how far we get. Okay, we see some bunch of so we see aggregation depth, right, of tree aggregate. It's interestingly linear regression, elastic net parameters. So I wonder if it's some things are loss function, what we optimized, right? Default is square error, right? What are you optimizing for, right? How far of the points from the value are. So also memory usage you can adjust if you have huge data set. So some things again, but we'll stick in general. We are going to stick with just our basic parameters. Okay, so let's do it. Let's do this. So it's basically we're gonna do fit, right? So well, I will do LR model, and basically we don't have to do anything else. It's kind of interesting here, right? We can use fit, right? Line reg fit, right? We can already fit the data set. So what our data set is, our data set is NDF, right? So this actually should know. So this already creates a model we can use for predictions, right? We can use for predictions. Again, of course, it's remember, it's kind of hard to can we do prediction? Let's see. So LR model, can we do predict, right? We need the features, right? We need the features. So if I do 1000, like I need to do, I remember how we did this before. Vectors, right? I think it was here, right? Where is vector? Right, we could try to already predict something. Vectorizer, right? Count no. Right, I don't want to do vector assembler. I want to do just regular vector, basically, right? Where do we have it here somewhere? Ah, vectors here, right? So vectors. Yeah, dense. Okay, something like this, right? So I just simple value, right? I could do this vectors dense, you know, just one value, basically, right? So vectors dense, this should work. Vectors dense. So where is our yeah, vectors dense? Ah, there we go. So predict vectors dense, I don't know, 1000, right? We need to, of course, import it. Come on, import class ML, right? First value, right? This should be print line. Let's see how it worked, right? So we can make predictions again. We can also already use it to make predictions, right? And of course, I could do Control D, you know, dense maybe minus 1000, right? Or minus, you know. Let's try this. Okay, so let's run it. See how well it works. Just need to pass in vectors type, right? It should work. Again, Scala strong typing protects us from making most of the basic errors, right? Which is good. But of course, since this is a linear regression, we can also you can get the formula, right? You don't need to, right? You don't, yeah. So it works 4006 and 3996. So it makes prediction. All right, looks pretty good. What's the formula? We already remember. We sort of cheated, right? We know that it's 4x plus 5. And that looks pretty damn, I would say, okay, pretty close, right? 4 plus 5 looks very, very close, right? There is some extra there looks like there's an offset, right? So it's not exact match, but it looks very, very close to our true values, especially considering that there is noise, right? This random noise, of course, could affect the model. So this is very good. Good performance, of course, right, for regression. If there's a linear relationship, of course, it will find it. It will find it, and it will do a very good job of it. So you might want basically get a summary, right? We can see the errors. So well, summary will be something like this. LR model summary, right? This is basically summary. We can do basically summary residuals, right? This is data frame. We can show the errors basically. Let's do like 10, right? Show residuals are the errors, right? Right, you know, differences from actual values, right? Okay, and also what we want probably, right? We want the intercept, right? In a linear regression, we want the intercept, right? You know, if you have, which is basically, so this is probably, you know, you have ax plus b, intercept will be b, right? And coefficient, right? Coefficients are the a values, a values, so here, you could have, of course, multiple values. So each a, so a value for a, so a1 for, if you have for multiple features, you would have a1, a2, a3, etc. Right? So like three-dimensional features would be a a1, x1, a1 x, times, I'm using algebra, of course, here, a2 times x2, right? A3 times x3, right? Plus intercept, which is b, right? Basically, right? That's what we will get. Okay, but here it's easier, of course. We only have one value, so we can do, well, intercept is going to be, of course, LR model intercept, right? Yep, there it is. That's a double, right? So this is our b, this is our b, right? And of course here we have our coefficient. Coefficient will be, of course, coefficient will be LR model, coefficients, and this is a vector, right? So we want, of course, 0, right? Or head. Can you do head? No. To array and head we can do head, but we can do just head. We just do basic coefficient 0, right? So first one, we only have one feature, so first one, right? Okay, and now we can see print line, intercept is intercept and coefficient is okay. All right, now let's take a look, right? So we should get a formula, right? So this will lead basically to AX. So we will find out. So we will find out, or y, equals AX, plus B, right? Right. So coefficient, first one, A, right? Okay. Of course, sometimes I use KX plus something, right? I use AX plus B, but okay. So very simple stuff. Well, let's take a look. Well, slowly we have time. Oh, we're doing pretty good. We have a few more minutes we can do. Okay. Intercept is 5, almost 5, and coefficient is 4, right? So very close. Again, considering the data, of course, is not clean, right? Here we see so you can see the residuals. Okay, so what are the residuals? Those are differences between the actual answer, right, and the what our group was given. So question is residuals, what type is it? Is a column? It's a data frame actually. We could basically join the data frame. So it's a single column data frame. So you could basically, I guess you could add the residuals to or existing NDF perhaps if you want to see the predictions, right? Predict, right? You could also predict from somewhere else, right? You could do, right? Predict will take, I think, also breaks other things as well, right? Right, transform, or we can do transform, right? Predict, we can also do transform as well, right? Yeah, predict, we can use that as well. Yeah, so of course, if we can do this, let's see, we have 2 times. Let's try this, get these answers. So these residuals, right? We could do this predictions, predict df will be what? NDF transform. Not like that. LR model. Now transform, right? And we want to give it a NDF, right? Again, we of course we would also want to have a test set to check our model. Of course, right here we used all, right? But let's take a look. So this should be predictions, right? So so predict df show 10, right? False, right? Okay, yeah, so it works. So you can see value and prediction, right? So that's why you see the residuals, of course, are the difference. Do we see the difference here, right? 0.01, which I think is exactly what's happening here, right? Roughly. We can, of course, do that. We can calculate the residuals, of course, by our hand, right? Transform with, right? And transform, and we can do this with column, right? Dot, called residual. and I'll call it so basically expression, right? Value minus prediction, right? I don't know, I guess which one comes first, right? And again I need expression, of course, right? Okay, right? So what do I have this? I don't need this, right? I don't know. Yeah, okay. Yeah. So we'll have also the, you know, just a column which is the answer here. Let's run it. So then we'll get to the exercise. So as you can imagine, yeah, so you can see the residuals 1.4 something, and it's exactly same here, right? Maybe 0.009, yeah, exactly same thing. So we did our by hand, right? So same thing exactly, right? These little errors, right? So residuals are our errors, right? So, right, okay. So we have a model. We could use it again. We can see it how we can use it. Transform, right? So we can check, right? We can use transform, right? So we use transform of our model to, you know, to make multiple, you know, predictions on some data frame, right? You know, of course, why? What are we using as our feature? Of course, we need the features column, right? The features column, of course, as well. Right. Okay, so we see this works pretty well. Okay, so what I'll do is I'll make you some more fake data, right? I will create you a new column. Basically, I'll use extra columns, I think, right? Yeah, I'll make some extra columns, right? So I'll call some extra columns, and maybe I'll make a new one. So 3D. So I'll do this while 3df, right now. df 3d, right? Maybe something like this, right? Yeah. And so again, Spark range, right? Something simple, right? And this will be just fake data. 2df, of course, right? Okay, not like that, right? Oh, sorry. And now, which is, you know, we'll call it with column renamed, of course, again we'll use ad to x1, so you know this is x1, not x, right? And with column, right, x2, yeah, of course, column x2 will be expression, you know, something like x1 plus 30 maybe. Yeah, why not? Right? And add with column x3, right? Of course, x3. And we'll do expression again, x1, I don't know, minus 20, right? Okay. And that's one more column, right? Column y, of course, and this will be, we need to come up with a good expression here. So let's do an expression. What can we come up with? So maybe we'll do round, right? We'll have an offset. Offset will be 50, right? Plus x1 times, I don't know, plus x1, right? So that should be 1, right? Plus x2 times, I don't know, 3 on, right, plus, you know, I guess I'll make it times 2, yeah, times 2, so plus x3 times 5, right, And we of course want some noise, right? Just because I'm faking data, right? So randomness, and again maybe slightly more noise. Randomness times 2 minus 2, right? Let's see, that works, right? From 2 to minus 2, right? No. Let's see, minus 1, right? Minus 1, right? Yeah. So yeah, so it's from 1 to minus 1 to 1, right? So a little bit extra noise, right? A little extra noise, right? And after all this, we're gonna again, let's do 4 digits after a comma. Again, there's some fake data, right? And so we have, so your answers are 2, 3, so intercept is 50, answer is 2, 3, and 5. Okay, and we'll save all of this too. Of course, we are going to save it, right? df3d show, 5 false, and we are gonna save it, basically, right? Basically, we'll call it 3D, right? Of course, format CSV, and we want pass option path equals, I'll just do it here, source resources CSV range 3D, maybe like this, right? Yep, that's good. And of course we want to keep the header option header true, right? And mode override, we don't really, right? And I'll save it, of course, right? And of course, one thing I want to do, I want to keep the original data. I'm too lazy. I'll keep this option. I will comment this out, right? So, I'm not gonna, I don't want to overwrite. So remember, I don't know if it's actually by default. I forget now. We'll see what happens actually, right? If it does, I forgot was overwrite was not default. Maybe I'll need. Okay, let's run it. Of course, not the end. We only have it committed to the GitHub, so not the end of the world. Okay, did we do something wrong? Yeah, probably, because file already exists. Okay, so yeah, it doesn't exist, so it basically yeah, so of course I could just basically not write, right? I'll leave it in, but I will not write, right? So it throws an exception if I don't have overwrite mode. It throws an exception, so I'll basically just skip this part here, right? And I will write a new one, right? Let's see if my formula worked. Okay, what is wrong here with me? There is a formal problem is here. Oh yeah, comma. Yep. Okay, let's do it one more time. It tells you exactly where the error was. Of course, I forgot to close the parentheses. That's the problem with expressions, of course. And as you can see, of course, you know where this is leading to. Right, yeah, so we have our features, right, x1, x2, x3, right, and they have some coefficients, right, so I want you to find, so your task is to, right, so your task is to open up this, right, so here, so to do, open, yes, transform x1, x2, x3 into features, y can be transferred into, so you can use vector assembler, right? The features you can use the vector assembler or R formula, right? Which are easier. Y can stay, or you can use label, label value column, right? And of course create linear regressor model, fit it to our 3D data, right? And of course, then print out intercept, print out coefficients, all three coefficients, right? And maybe make a prediction, make a prediction if values are, you know, say 10, 50, you know, on if values of x1, x2 and x3 are respectively, let's say, I don't know, 100, 50 and 1000. Let's see what happens, right? Let's see if this, how well this works, right? Because they have three-dimensional space, right? So let's see how that works, right? All right, and that's it. Pretty simple, right? To do. All right. So I'll see you at 9, and we will look at some more regressions.